Hello and welcome to another UniDec tutorial video. My name is John Pavic. I'm a postdoc in the Marty Lab, and today I will be talking to you about using IsoDec, our algorithm for deconvolution of high-resolution isotopically resolved mass spec data, and using that to process single spectra. So we're going to start at our usual UniDec launching page. We'll hit the IsoDec tab, and we gotta have some data to work with. So we're gonna work with this raw file. It's 1500 scans of ETD fragmented carbonic anhydrase that have then been averaged. So we're gonna load that. This initial data is profile mode, which IsoDec cannot handle. So we first have to centroid it so we can actually run IsoDec on it. So we're going to leave this data is centroided checkbox unchecked, hit process data. Now we have our centroided data. So now we'll step through some of the deconvolution parameters. The cosine similarity score threshold is the minimum cosine similarity between an experimental envelope and a theoretical distribution that has been predicted for that envelope. If it doesn't meet this threshold, it will not be accepted as a deconvolved mass. The match tolerance corresponds to how closely experimental and theoretical peaks must match. I think it's worth noting that this isn't like a database matching tolerance where like it's highly dependent on the calibration of your instrument. This is more about the repeating spacing of isotope peaks within a single charge state. So this can be relatively low because it's essentially like a relative spacing thing, not an absolute tolerance issue. So basically, if this were like a plus 10, we would expect the spacing between each isotope peak to be 0.1 m/z. And this 5 ppm tolerance corresponds to how much wiggle room there is around that particular like m/z spacing. So then the number of knockdown rounds, which kind of controls how deep into the spectrum you're digging with IsoDec. So basically the way IsoDec works is it basically iterates across the entire spectrum and selects local maxima within a particular peak detection window. It selects those maxima and then isolates a region of plus 2.05 to minus 1.05 around that maximum, and then sends those to a charge assignment neural net, which guesses the charge, and then we score a theoretical distribution of that charge against that experimental data. And knockdown rounds corresponds to how many times you repeat the process of like iterating across the spectrum, selecting centroids, encoding them, passing them to the neural net, scoring them, and then knocking down the matched peaks. The max monoisotopic shift corresponds to, let's say we're looking at this particular envelope. So the max monoisotopic shift corresponds to how many isotope peaks either to the left or the right the theoretical distribution is shifted relative to this. Basically what this does is like, this is a pretty clean distribution, but in cases where we have kind of uglier, noisier distributions, that can allow us to more accurately determine the correct monoisotopic mass, where the most intense peaks in the experimental and theoretical spectrum shouldn't line up. And the highest scoring shift is then calculated back to a monoisotopic mass, and the highest scoring one is reported as the monoisotopic mass for that envelope. Although if multiple shifts meet that meet our filtering criteria, they will also be returned. So now that we've kind of discussed what some of these parameters in IsoDec are, we can run it. Should take a couple seconds, and now we have our deconvolved mass spectrum. So each of these corresponds to a particular individual mass, or an like deconvolved mass of one of these isotopic envelopes. So we can, let's close these parameters. So we can label these peaks. There's a lot of them, so this gets quite messy. We can also plot the isotope distributions below them. So now we can kind of zoom in and get a better idea of what's going on in that scoring and shifting stage of the algorithm. So here's an example where it looks like this may have been the most abundant peak. These two are pretty close, but basically the max monoisotopic shift corresponds to how many isotope peaks this whole distribution would be shifted relative to this experimental distribution for scoring. So now that we have this set of deconvolved masses, what can we really do with it? One thing you can do is search it in Prosight Lite. So let's open up Prosight Lite. To import our data into there, you're going to right-click on this table and do Copy All Basic. Go to Add Experimental Data in Prosight Lite. Just paste that in. You do need to delete the headers here. This is ETD data, so we're going to select that and save. So now that we've got our experimental data in, we also need the sequence of carbonic anhydrase. I have it pasted in this text file just for easy access because carbonic anhydrase is a classic. So we're going to paste that in here and we're ready to go. You can see we don't have great fragment coverage. It's because carbonic anhydrase has an acetylation on that N-terminal serine. So we add that acetylation, we get up to about nearly 70% sequence coverage. So we got pretty great depth. So in addition to processing in Prosight Lite, depending on your parameters, I selected MS-Align export, so that allows us to also process this data in MASH native as well. So to do that, we also need to import the raw file, and then we can go File, Import Results, Import Mass List. MS-Align is the msdconv/topfd file output type. So we're going to do msdconv or topfd mass list. It gets output, so our file name is 1500 scans, 200K, 16 fills, QB1. So we're going to go to the UniDec files for that, and we're going to select the MS2 MS-Align because this is a fragmentation spectrum. So that's going to load. We also will then need to add our carbonic anhydrase sequence in here. Got that loaded. We're going to add that acetylation. It's ETD, so we're looking for C and Z fragment ions, and lo and behold, so currently we have a pretty wide mass tolerance. We're going to take that down to 10 ppm because 1.1 Daltons is pretty wide for that. So now we're getting pretty much the same sequence coverage we saw in Prosight Lite, about 68%. So these are a few different ways that you can process that data that is exported by IsoDec. Additionally, if you just want a clean TSV of the data, we also export the most abundant MZ, monoisotopic mass, scan, and most abundant mass and relative abundance in just an easy to read TSV file format. So if you have other uses or just looking to kind of like manually putter through and figure out what's going on with in your spectrum, that is another way you can work with it. So I hope this was helpful in kind of giving you an introduction to working with single spectrum data using IsoDec. And stay tuned for more IsoDec tutorial videos. Thank you.